In this question, we are going to show this result. If you understand the definition, then this result comes straightforward. Why is it so? Because this represents the minimum degree in G, and this is the maximum degree in G. And what does it mean? This is actually means that the average degree. So definitely average is in between the minimum and maximum. Let X be a vertex in G. And for any vertex in G, the degree of X must be in between the minimum degree and the maximum degree. Then we take the sum of all of this for all X inside G. By Heng-Shui lemma, the summation of the degree is equal to the double of the size. It's equal to double of the size. And what does it mean here? For any vertex S, I need to add delta G. And since they are VG, so altogether I will have this much of value for this summation. Likewise, we will have delta G and VG. Therefore, we have this inequality. Let G be a graph, or rather, let G be a simple graph with a size of 35 and minimum degree of 3. We are asked to find the maximum value of the order of G. It means that we want to find the maximum number of the vertices in G. So using the inequality that we have, double of the size over order is in between the minimum and the maximum degree of G. In order to get this value, we use this part of the inequality. It's known that this is 3, this is 2 of 35, and this is unknown. So Vg will be less than or equal to 70 over 3. That is 23, 1 over 3. Now because the order of G is an integer, so this is less than or equal to 23. Now we always have to see this is equal to 23. This means that the maximum is 23. In other words, we want to ask, is this number achievable? So we have to think of a possibility of such graph. This is an example of a graph tree on 23 vertices, where most of the vertices are of degree 3, except for one is of degree 4. And you see that it will fulfill these two conditions. So in other words, a graph of 23 vertices that fulfill these two conditions is possible. So the answer for this is equal to 23. Okay, question 3. You have a simple graph, order 8 and size 15. For each of the vertex is either degree 3 or degree 5. So the question asks, how many degree 5 vertices? After which, construct one such graph G. So we may suppose G contains A degree 3 vertices and B degree 5 vertices. So we may suppose G contains A degree 3 vertices and B degree 5 vertices. And what does it mean? It means that the sum from here is equal to 8. For one degree 3 vertex, the sum of the degree is 3. For A degree 3 vertices, the sum of the degree is equal to 3A. Likewise for the second one, the sum of the degree of 5 vertices is equal to 5B. And we already know that the sum of the degree for all vertices in G is equal to double of the size. Our task is just to solve the simultaneous equation. So after solving the simultaneous equation, then we will know that A is actually equal to 5 and B equals to 3. 5 and 3 is 8. This is 5, so it's 15. This is 3, so it's 15. And you have 2 15. One such graph G is simple. We just say that there are two kinds of graph. One is of degree 3 and one is degree 5. Then we can say that it may be like 3 here and 5 there. And each of these has 5 friends. Each of these have 5 friends. And we complete our task. You see that for degree 3, you have 5 of them. And for degree 5, you have 3 of them. So this is done. And we say that this is a bipartite graph K35. So this is for part 2. This question 4 is quite similar to what we have in question 3. It's just that it has some additional condition. So the order of graph H is 8 and the size is equals to 18. Given that the minimum degree is 2 and maximum is 4. Suppose Ni is the number of degree I vertices. And assume that there are some vertex of degree 3. We are asked to find all the possible value for these triples. After that, construct one such graph for each of the possible solutions. With this definition, then we know that N2 is the number of degree 2 vertices, N3 and N4. And we can only have N2, N3, N4 because of this condition. The sum is equal to 8. 2 of N2, 3 of N3, 4 of N4 is in fact the sum of the degree. So this is the sum of degree. And it will be equal to double of the size. Double of the size, that is 26. Don't forget that N3 is at least equal to 1. So our task is just solve this simultaneous equation. So we can say this is 1 and 2, and we consider 2 minus double of 1. Note that 2 and 10 are even numbers, so N3 has to be an even number as well. And because it must be at least 1, N3 must be at least 2. If N3 equals to 2, then N4 will be equal to 4. And N3 equals to 4, then N4 will be equals to 3. If N3 equals to 6, N4 will equals to 2. But we do not accept this answer because the sum of this is already equals to 8. Then it will mean that N2 will be equals to 0. It will contradict to the condition here. So we have only 2 sets of answer. N3 equals to 2, N4 equals to 4, N3 equals to 4, N4 equals to 3. And therefore, the solution that we have here will be equal to 2, 2, 4, or 1, 4, 3. In order to draw out such graph, let's say for this one, the degree is at least 2, so we can draw a circle on 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. Each of these is already of degree 2. So let's say we can add in this way. This is a degree 4, this is degree 4, and this is degree 4, degree 4, and 2 of degree 3. So I'll just label the degree. So this is 4, 2, 4, 4, 4, 2, 3, and 3. And this is one of the example. Next, we can do quite a similar thing to this. 1, 2, 3, 4, 5, 6, 7, 8. Because there's only 3 of degree 4, we can add this in stage. So this is 4, 4, and 4. 4 of degree 3, so I can just do in this way. So this is 3, 3, 3, 3. Right? So in fact, there are many possible graphs for each of these. This is just an example for each of it.